In this problem, we're given 27 high-interest mortgages, and in my example here, 39 low-interest mortgages. And for each of those, we've calculated a mean FICO score, that's the Fair Isaac Corporation credit score, essentially, of 720 for the high-interest and 737 for the low-interest mortgages. In theory, anytime you have a better credit score, you qualify for a lower interest on a loan. And then for the high interest mortgages, we also have a standard deviation of 49. Now keep in mind, that's a sample standard deviation. We also have a sample standard deviation of 45 for the low interest mortgages. And why I emphasize that is because if we knew the population standard deviation, then this hypothesis test would be done a little bit differently. But most of the ones we deal with will be sample standard deviations, as is the case here. All right, so we're supposed to test the claim that the mean FICO score of folks with high interest mortgages is lower, so that's key, is lower than the mean FICO score of borrowers with low interest mortgages. And we want to use a 0.1 significance level. So the way we always start these out is identify the claim and the opposite. So the claim, that's why I circled this lower, is that, well, we're dealing with mean, so I'm going to use my mu symbol. Lower suggests that we use the less than symbol, and then mean. And I'm going to label these mu1 and mu2, and I generally look at this as the first one I read, that is high interest mortgages, that'll be my sample 1, and my low interest will be my sample 2, because that came second. Then the opposite of this will be mean 1 is greater than or equal to mu 2. Now look at which one has the equal sign. It's the opposite in this case, so that corresponds to H naught, the null hypothesis, and we change that to equals. That means the claim corresponds to the alternative hypothesis, which is not equals, it's less than. So mu1 is less than mu2. All right, now let's calculate the test statistic. And I guess in the homework, it asks us whether this is a left tail, right tail, or two tail. And because my alternative hypothesis is less than, you could think of this guy, if it's less than or greater than, this guy points to which tail it is. So it's pointing to the left tail. So this is a left tail test. So now we calculate the test statistic. And to do that, we use the formula x bar 1 minus x bar 2 over square root of s1 squared over n1 plus s2 squared over n2. So I look at my sample mean. For the first group, the high interest group was 720 and the low interest group was 737. Now one thing to recognize is that these two numbers up top here, that will get you either the positive or negative test statistic. In this case, I'll get negative because I'm subtracting a larger number from a smaller number. And that's what we want in a left tail test. Left tail tests should have negative test statistics. Right tail test should have positive. And a two tail test, it's anybody's guess. So you could get either positive or negative. Okay, so my standard deviation of my first group is 49, and I'm going to square that. And I had 27 of those guys. And then we'll add, we had 39 of these guys, and their standard deviation was 45. Okay, so now let me demonstrate how to put this in a calculator in one line. So I'm going to start out wrapping my numerator in parentheses, 720 minus 737. divided by, and now square root, and I'm going to wrap this whole thing in parentheses, 49 squared divided by 27 plus 45 squared divided by 39. And you could use more parentheses just to be sure, but orders of operations should hold so that the squaring is done before dividing, which is what you'd have in this fraction. The squaring would be done before dividing. Exponents come before division. Okay, so that gets us a test statistic of about negative 1.432. Okay, so now we need to find, in this problem, we're going to go the critical value method because the homework question is asking us about the critical value instead of the p-value. But to do that, first we need to know the degrees of freedom. And for our purposes, we're simply taking the smaller of the two n's, so 27 and 39, and we're going to subtract 1 from it. So I took the smaller one, I'm subtracting 1, so our degrees of freedom is 26. And my significance level, we need that for the critical value, is 0.1. So I'm going to look on my table first of all, then I'll do the same thing in Google Sheets, but I'm going to look on the table, row 26, in the 0.1 column, and specifically 0.1 in one tail because it's a left tail test as opposed to a two tail test. So I look for 0.1 in one tail, not the one in two tails. One in one tail, and I go down to row 26, and my critical value is 1.315. However, keep in mind, since this is a left tail test, it's negative. Now, to do a critical value method, I am comparing my test statistic to my critical value. If my test statistic is further into the tail than my critical value, I reject the null hypothesis. So thinking about this on a bell curve, I've got my critical value at negative 1, so 0 is in the middle, of course. So my critical value, negative 1.315, would be here. My test statistic, negative 1.432, is further into the left tail. So that tells me to reject the null hypothesis. Now, if we go back up here and look at what happens when I reject the null hypothesis, well, I'm essentially rejecting the opposite. And since I didn't cross out the claim in that move, that means in this particular case, because my null hypothesis was with the opposite and I rejected it, that means there is enough evidence to support the claim. Okay, so let me go through really quick and show you how to find the critical value on Google Sheets. And again, all I need is the degrees of freedom and the significance level, 0.1. By the way, the significance level is the area that is to the left of my critical value. If this was a right tail test, the significance level is the area to the right of my critical value. So I need to find that critical value that has 0.1 to the left of it. And to do that, I'm going to use the t.inv function. Let's increase the size here. t.inv, the inverse t function, and the probability is 0.01. That's my 0.1, I believe it was. Significance level, and degrees of freedom was 26. And that gets me about negative 1.315, which is what we ended up using.